Good morning, everyone. And first, I have to say to Naveed, excellent haircut today. Also, Nissan looking pretty fly as well. Brayden, did you get a haircut?
I cut my hair every couple weeks, so nothing special, to be honest.
Looks good. Today we're gonna do building. We're gonna be building and training neural networks with Python. So the assignment was just to take one of the past regression projects that we did, which was either linear regression or logistic regression for classification, and to recreate the project using a neural network and to see if the accuracy of the deep learning model was better than the traditional machine learning model. So we'll start with Nishant, and let's have a look at what you did. Okay.
Yeah. So basically, I made a neural network, and I think he made a class called sequential, and then he made. I'm not exactly sure what. I think dense makes it to make it smaller, and then dropout as basically.
Yeah. So just
I'm
starting
not
from
really sure what dropout really
starting from
does.
the top, what library does sequential come from?
Keras, TensorFlow.
Yeah. Keras, which is like part of TensorFlow now.
Yeah.
So basically, sequential is it's a normal neural network. It's a feed-forward neural network. You can just think of it as a neural network. And a dense layer, right, Naveed, is just a layer where all of the outputs are connected to the inputs of the next layer. Isn't that right, Naveed?
Yeah, so the dense layer is just a fully connected neural network. Probably the simplest one that we were talking about, where every single unit is just can call it a logistic unit, but the iteration function that is used is ReLU. So it's just a simple feed-forward neural network layer.
Got it. So how many layers does your network have, Nishant? So
it doesn't say how many layers, but it has 3 features.
Look at this.
Aid, embark, and fair.
Good. Yeah, so it has 3 features, and then look at the sequential class. That part where it says sequential. Yeah, here. So you have 3 dense layers, and then you actually have 2 dropout layers, which is something that we haven't really covered yet. But yeah. So I guess Naveed, would that make it 5 layers?
Yeah. So we have two hidden layers. One is the input layer, and then one is the output layer. So in total, we have 1, 2, 3, 4 layers in this network.
Oh, because you don't count the output layer?
I am counting that. So if you see, we have 2 hidden layers, right? Dense 32 and then dense 16. And then the final one is the output, because he has used softmax with 2 neurons. So this is basically the final layer where it classifies the output. That's why we have 3 here. And if you count the input layer, then in total we have 4.
Okay, got it.
Does it make sense?
So the dense layers count, the input layer count, but the dropouts are not actually layers, so they don't count.
Dropout is it's not a layer. You just simply drop some of the weights at random. The dropouts are used to curb overfitting. ChatGPT is using a huge dropout amount 0.5, meaning 50% of the weights are dropped during the training. I'm not sure how this performed, this network, but I think it wouldn't have performed really good.
Okay. Nishant, do you remember what the performance of the first model that you did was?
Yeah, I asked it too.
Okay.
81%. See?
So this has, we have validation accuracy 81%. And I believe that what was the accuracy from the logistic regression? It was
Exactly the same.
exactly the same.
Yeah.
That's interesting. Okay. Cool. Do you want to see if we can also run this in Google Colab? That might be, I think we could probably do that in 10 minutes, and I think it would be worthwhile.
Sure.
So yeah, just try making a new collab and then copying and pasting probably the last version of the code
Yeah.
into that. How long did it, by the way, how long did it take to run in ChatGPT?
Really quick, like 10 minutes maybe.
You mean to run the model? To train and run the model?
Like inside itself, I think it was really quick, like maybe like 10 seconds there. But like to like
Yeah.
get all the stuff and reprocess it took a while.
The I'm sure that ChatGPT has a ChatGPT code interpreter is what it's called, has a timeout.
I imagine they don't let you train models in ChatGPT. That would be a nice hack to get some free compute. I don't think they let you do that.
That's also something I'm thinking. I mean, they usually don't provide compute capacity. If it is something simple like just interpreting some data, plotting something, it does. But
Yeah.
training a neural network is it would require a lot of compute power.
Well,
No,
we could
they actually also have GPT-4 for free as well now too. Technically, because they
Yeah,
gave
no,
4.0 for everyone. So
providing GPT is one thing, but when you task it to run the code, obviously it will be taking that code and running it somewhere. So that would require extra compute power.
Yeah. So I think that they probably limit the I think they probably limit the resources carefully. So I wouldn't be surprised if you could train a very, very, very simple neural network on it.
Yeah, this network
That it was
is fairly simple, so it would be
Yeah.
trained really quickly even on a simple CPU.
Aditya, want to share your screen? But yeah, there's definitely a timeout in seconds. So I think you'll eventually, I don't know what it is, maybe 2 minutes. I'm just Googling around. But so basically, if you run any Python script past that, it'll just exit. So that's why running this in Colab is going to be so useful, because you can still actually generate the code with ChatGPT. That's no problem. Then you copy and paste it in Colab. You can train something a little bit more advanced. You got Colab open?
yeah.
Oh, we don't see your screen anymore.
Oh, okay.
Yeah. Let's see if we can chat. Okay, let's see. Here. Cool. So yeah, so good call to upload that
Yeah.
into Colab. Have you used Colab much?
No,
Nishant, you already
no.
have the Titanic.zip in Colab environment. Why don't you just unzip it there?
Oh yeah. So to unzip, you
Yeah,
would
create a
so,
new cell.
go ahead, Naveed.
Yeah, simply create a new cell and uh, write first. Put an exclamation sign so that we can let it know that it's a bash command, and write unzip dash q dash q. Just I think suppresses the output.
Wait, can you repeat that?
Yeah, just dash and then q.
Mhm.
And now the name of the file, which is titanic.zip. Yeah, just run it now. So you now have the 3 files there. If you refresh the
Yeah, no, not
the
that one. Cancel.
No.
Refresh.
yeah,
Yeah, perfect.
that's,
Oh,
that's
okay.
there. It it's not reading dataset anywhere. Can you scroll up a bit? Yeah, you first have to read this dataset using
Yeah.
pandas.
That.
Yeah, there were also some undefined functions, so it's possible that this is the second half of the code.
Yeah.
So yeah, is there
Scroll up. Maybe it has provided you the code earlier.
No, that's
And
from
then
the
see.
logistic regression part.
Oh,
Yeah, because I made the correlation matrix.
let's see.
can you, James? Can you paste the loading the dataset code to the chat, or maybe I should do
Yeah,
that.
yeah, sure. You can do that. Aditya, what else you could try doing is you could just ask ChatGPT to repeat the whole code, but tell it that you're working in Colab and you need to import the CSV file.
Oh, okay.
So try that. And
Don't you guys? Isn't there code on the GitHub for importing the Panda dataset?
yeah, we have an
Yeah,
example up there as well.
it is there.
Okay. Oh, wait. This one.
Yeah, there you go. That's it.
There's an underscore uh, between read and CSV, not a dot. Yep, run it now. Oh, you have to import pandas first.
Oh, yeah, okay.
Pandas SPD.
Yeah.
Just right.
So
SPD.
pandas space. Yeah, perfect.
And just print the first 5 entries using titanic.head. You don't have to write the print statement, it would print it anyways.
Mm-hmm.
Yeah, and now you have to create the X train and the Y train. So for that, you first need to separate the features from the target in the pandas frame. So the target here is, what is the name of the target column? Can you scroll up? It's survived. So let me write the code in the chat.
Y train. All right, there it is. You got it in the chat now.
And then X would contain Titanic dot drop so we'll drop everything. We'll drop the survived column.
Yeah, so instead of the square brackets, do like do a dot and then drop.
Dot drop parentheses and then a square bracket, and now write in quotation the survived column because we don't want to use that as a feature. And can you scroll up if we have any other redundant stuff that we should be dropping? I think passengers ID is also something we don't need, so just put it there.
Okay.
In the square brackets with a comma.
Yeah, right after survive, but in the second line, in the next line.
In the second, yep.
Yeah. So what this line does is it takes every column except for those two.
Yep. I think there are columns like name. You need to also put that because we don't need that as well. Can you scroll up? Okay, the rest of them. I think we should drop cabin as well because we have lots of missing entries. And also the ticket one. Just drop all of them. Okay, what are we left with? Embarked. Okay. Can you scroll it towards the right? Or we don't have
that's
any.
the rightmost.
Okay. Yeah, run it now. So, but we have to convert the sex and the embarked ones to categorical, to numeric features because they're categorical characters. We have to convert them into numeric features. Run the cell above, the one that you created, not this one. Oh yeah, you have put it there. Okay. Can you just separate this code from the rest of the neural network?
Okay.
The X and Y. Just create a new cell and press it there.
Yeah, so put your cursor in the cell that you're adjusting. Okay, yeah, paste it in there.
Great. Yep. And now, okay. So now you have to. Maybe it would be better to ask ChatGPT to ask it what code you would be needing in order to convert these categorical features to numeric ones.
So Navi, can you just explain this chunk here, like the two categorical? Is that operating on all of the features?
So this to categorical, basically what it does is it takes the labels and convert them into one hot encoding because neural networks are accustomed to taking the labels in one hot encoded fashion. Because Aditya is using a softmax layer at the output, he's not modeling it using the sigmoid function, in which case we wouldn't have required this to categorical. He's treating it as a so he has created two classes, two output units. So what we would now be needing to do is, if the person survived, we would pass it two values. There would be 1 in the survived and 0 in the unsurvived one. and if the person doesn't survive, then there would be a 1 in the not survived and 0 in the survived.
Oh, right. Yeah.
In simple words, we are just simply putting or giving the neural network the output in one hot encoded fashion.
But so
Does
if
that make sense?
yeah, but so if we would do that on the X, you would
We don't
you don't
we
do this.
don't do that. Yeah, we don't do that for X. For
So
X, we just
yeah.
Mhm.
Mhm.
For X, we have to just do the categorical to numeric encoding for the features which have these characters in their name.
Yeah. So this is asking for y train and y val. Do we need the val?
Yeah, we would actually maybe it would be better, James, if I do this on my end and share my screen. What do you think?
Yeah, maybe you can share the notebook with Naveed.
Yeah, sure.
On the top right, there's a share. Yeah.
Let me share my screen. Do you see my screen?
Yep.
Yeah.
Okay, so let's take them from there and paste it here.
Mhm.
So if we run this now, I think I'd have to run this entire thing. And I don't have the Titanic. James, can you just quickly send me the link to this Titanic dataset?
Yeah. It's yeah. Got it.
Yep.
Hmm.
Why is it taking so long?
It's not loading for you.
Mm-hmm. Yeah, it's loaded now.
It's loaded. Okay. Say.
So I just loaded the trend.csv directly. I don't have to run this on zip. Not found. That's because passenger ID. Name, ticket, cabin.
Looks
The spellings are correct.
it
What's
looks
wrong then?
it looks right to me. But does it say which key it is?
It has mentioned all of it.
Oh, do you need you don't need the double square brackets, do you, for this one?
Ah, I think yeah. No,
Let's
let's
see.
see. Titanic. Oh, we have to. I think we also have to provide it the axes because by default
Yeah, I
the
remember.
axis is.
Axis is 1.
Yeah, so if you now take a look inside the X, we have P class,
Mhm.
sex, age, this, fair, and embarked. Rest of them are numeric, so we don't have to do anything with that. But this one and the embarked one are categorical values, so we have to convert them into numeric values. Uh,
Right.
label label encoder is used for that. Um, so what is doing it here is just simply taking the sex column, replacing it with the label encoder, which we have declared here as an object dot fit transform. So what the fit transform just simply do is it takes the sex column, assigns integer values to whatever categories we have. So like for the male, it would assign a value of 0. For the female, it would assign a value of 1. And then replace the entire column with zeros and ones instead of male and female. And it does the same for the embarked one. So it takes the original column and replace it with the integer encoded one. So if you run it and have a look, then you see this. And if you would like to take a look which value has got what integer number, you can just call its classes. So as you can see, this is in the numeric order. So like this is the C would got a value of 0, Q would got a value of 1, this would got a value, will get a value of uh, 0, 1, 2. We also have some missing entries here. So for the missing entries, we can just simply replace them with the average value, but I think that would not be a good idea because the average would introduce a new category here. For now, let's just simply drop it from the frame. Okay, what this command is simply, this one just drops the entire rows which contains missing entries, and then this is checking if there are any missing entries. So x dot is na checks if there are any na values, not available numbers. Dot any just simply, if you run it without this, this will individually give you true and false in places where we have values. It would be true in places where we don't have, sorry, in places where we have no values, it would be true, and in places where we would have values, it would be false. But if you call dot any on it, then it just simply checks the entire column. If there is even just one missing entry, it would return a true for the column. So once I uh, ran this cell, it dropped all the missing entries, and now by checking it, it just simply verifies that the entire columns do not have any missing entries. That's why you see a false in front of it. And now let's do this transformation once again. And if we run this, that 9 value is now gone. So at this stage, this is, I think, ready. But there's one other thing that we need to do, which would be what? Any guesses?
Oh yeah.
Normalizing the data.
Nishan, can you check what ChatGPT put out and see? Just look through the code and see if it's doing any normalization or if it's doing any cleaning of the of missing values? I'd just be interested to know.
So Naveed, the data normalization, does that map all of the values in the training set to like smaller numbers between like 0 and 1? So like whatever the range is, it just changes that to, or not between 0 and 1, but like between like -1 and 1, something like that.
Yeah, so it takes all the columns, like we have these different columns. So for every column, what it does is it first computes the mean of this entire column, and then it computes the standard deviation of the entire column. And then for every single value, it just subtracts the mean from it and divides it with the standard deviation of that respective column. And it does it for every single value. And if we now look at the result, columns equal to x columns, you'll now see that uh, these values have now been transformed. So previously, when you had 3, 1, 3, and these different scales, now every single value would be between some negative and some positive number.
I see. Makes sense. Thank you.
Okay, let's now create the trend to split.
Wow, Naveed, you're a fast typer.
That's because of this thing.
Yeah.
Okay, so you're just taking the normalized data, the features, and the corresponding target values, and putting a test split of 20%. Random state, when you specify to it a random state, each time you run this cell, this code, it would be creating those exact, uh, like those exact samples would be going to the training set and test set every single time you run it. If you don't put a random state here, each time it would be just simply assigning random examples to the training and test set. The reason we put a random state is because we would like to see if we make any changes to the maybe the model or to anything. We would like to test it on the exact same test set because we don't want that to be reshuffled. We don't want any changes introduced because of the changing of the test set itself. So putting a random state is usually a good thing. Did I run this? Found input rows inconsistent number of samples.
Look at the variable names. Do we use the same?
That's because I dropped values, not available numbers from the X, but those are still in the Y. So now the numbers don't match. So what I need to do is to drop those at the beginning of the data set. No, we don't need this one. Let's check if there are any missing entries. No. Okay, at this stage, the data is now ready to be given to the model. But for neural networks, just like I said, there's just one extra thing that you need to do. You can usually omit this if you make a change to the model. If you, instead of putting a softmax here, put a single neuron and make it sigmoid. So now you wouldn't require this thing. Let's check it out. And also we have to X trend, X wall, Y trend, Y wall. Wow, the model performs terrible.
What is it? What does it give?
Uh, Wait a second. We also need to change this to binary cross entropy now because we have replaced that with the sigmoid. And also just let's just remove these dropout layers. I'll talk about it in a second. Yeah, it's better now. Validation accuracy of 75. So the changes that I have made to this model
Mhm.
previously, the at the output we had two neurons here, and the activation was softmax. Now, what is softmax? If you look at the formula of softmax, it is what it does is um, if you have, let's say, a categorical problem, more than two classes, let's say four classes, every single output neuron would get some value. And what the softmax does is it converts those into probabilities, and it converts it in such a way that the summation of all the probabilities leads up to 1. So how does it do it? Well, it does it using this formula here. It takes the activations of every single neuron before applying the nonlinearity. It just simply computes the, what should we call it? Maybe the values for those z, and then it plugs it inside this formula. So for a particular class, for a particular neuron, if you want to compute its probability, uh, it plugs the output of that neuron here, and then it divides it with the summation of all of the rest of them. So what this yields as an output is a probability of that particular neuron. Does it make sense? I think it wouldn't. Let me just quickly grab my whiteboard.
Hey, can I just show something while you're doing that, Naveed?
Mm-hmm.
Okay, I just want to show something real quick. So, let's see. Here. So, Nishan. So this is your Chat GPT, right? Here.
Mhm.
So if you would, the code that you're looking at here is this first part. It generated some code to create a neural network using Keras, right? But this is not complete. But if you keep scrolling down, when you actually ask it to provide features, it gave an updated version of the code. This one. So the latest version that the ChatGPT ran is this one. If you copy that and then you paste that into Colab, that code works. That code works as is without any changes. The only thing that I had to change to get that to work was to change path to train to train, which is the name of the file that I uploaded. And then this worked. This ran without any changes, and it gave this validation accuracy of 79, which is slightly different than what ChatGPT got, which is 81. So I wonder if there could be any randomness involved here. Possibly if I run it again, it would be different. But yeah, I just wanted to show you that if ChatGPT, if it works in ChatGPT, what I'm trying to say is if it works in ChatGPT, that it will also work in Google Colab as well. Like
Hmm.
it's Python code, it will run anywhere. So I just want to show you that. That's all.
I see. That's cool.
Just make sure that you're copying the right thing. That's all.
Got it. Sounds good.
Yeah. Okay, Naveed.
Is my screen shared?
Mm-hmm.
Yeah.
Okay, so let's first talk about how can we deal how does a neural network deal with the binary classification problem and with a multi-class classification problem? So suppose we're just talking about the output. So if we have a, let's say if we have a binary classification task, we can do it. The simplest way to do it would be just to declare a single neuron at the output, and whatever this previous layer could be, you can have like, let's say, whatever number of neurons in the previous hidden layer, and all of them would be connected to this output neuron using some set of weights. The way this output would be computed would be something like this. So you would, let's say, have weights for it, W1 times whatever this number is, W2 times whatever this number is, and so on. So the output would be equals to, um, let's call it A1, A2, dot, 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 AN, and this W1, W2, and WN. The output would be A1, W1 plus A2, W2 plus dot, 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 AN, WN plus that bias term. And you can apply a sigmoid to this thing. So whatever output here is, let's call it Z. That's our Z. And then when you apply the sigmoid activation on Z, this yields probability, which varies between a 0 and a 1. Because if you remember, the sigmoid, what it does is it just simply takes the output and squash it between 0 and 1. So if this value is negative, it asymptotes at 0, and if it is positive, the greater the value for this Z, so that this x-axis here represents the Z, the greater the value, it asymptotes at 1. And then once it yields an output, that would be a probability. You can just simply put a threshold there. Let's say the threshold is 0.5, and we say if the output is, let's say, greater than 0.5, automatically the result would be a 1, a logical 1, and if it is lesser than 0.5, the output would be a 0. And that's how you can achieve uh, binary classification using this neural network. Does this make sense?
So what you're explaining is the last line of code in the neural network, which is the dense layer with activation equals softmax, right?
Exactly. So this is exactly what I have done. I have put a simple single neuron cell here, and the activation that I've applied is sigmoid.
Okay.
And then the corresponding loss function that I'm using is binary cross entropy. Now, what would be the case if we would like to do multi-class classification with this neural network?
Right.
So the way to do multi-class classification, obviously we cannot do it using binary, using the sigmoid, because the sigmoid is just yielding a probability between 0 and 1. We can also do that with sigmoid, but a more stable way of doing it would be using a softmax activation function. So let's talk about that. Suppose we want to do there are three classes. We want to do classification here. The way to do it is we declare 3 neurons at the output. And so this is our output layer. And whatever previous hidden layer we have, it would be connected. Let's say we have dot dot dot. This is A1, A2, and AN. Now, every single neuron in this output layer would be connected to every single cell in the previous hidden layer using some weights. So how can we, so suppose, so this cell represents class 1, this cell represents class 2, and this cell represents class 3. How do we convert this into probabilities? So the way to do it is, let's call it Z1, Z2, and Z3. Now this Z1 is nothing but the 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 weight associated with every single connection that arises from the previous layer and that respective unit there. So it would be W1 A1 plus W2 A2 plus W3 A3 in a bias term. That's how we compute Z. But remember, right now we are not applying any activation function on it. This is Z. This value would be some number. How do we compute Z2? We compute it in the exact same manner because now this Z2 is also connected to these previous hidden units using some set of weights. Those weights would be of course different from the ones associated with this Z. So what this softmax actually do is it takes, so suppose I want to compute the probability, how much is the probability that this example belongs to class 1. The way it computes it is it takes the Z value for that particular neuron, which is this thing, it plugs it in here in the exponent, and it divides it with the summation of the Z values for the entire output layer neurons. So it would take the Z value of this and this and this, plug it in the power of E, and sum all of them together. Does this make sense? Let me paint this in different colors. This is Z1, this is Z2, and then we have a Z3. How do we compute Z3? Z3 has its own respective weight, so let's call it W1, W2, and W3. But don't confuse it with the blue W1, W2, W3. We have different color here, so different color just simply means different number. So it would be W1, A1. That thing remains the same, so that A1 remains the same value coming from the previous layer.
Yeah.
There will be a different bias. That is the value for Z3, and for Z2 it would be connected with it using a different set of weights. So we will have W1 plus W2 plus W3 plus B, and the A value stays the same. So we have A1, A2, and A3. Does this make sense to you?
Yeah, I think we understand.
Okay. How do we compute the probability that this example belongs to class 1? We just simply take Z1, plug it in the power of E, and divide it with e to Z1 plus e to the power of Z2 plus e to the power of Z3. That's how you compute the probability that this example belongs to class 1. Does this make sense now?
Yeah, so basically what softmax does is it's just you have three like real numbers basically, or like you have an array of real numbers, and then you're trying to find out which one is most likely. So you just compute basically it's just converting it to like a set of percentages. Like each value in the
Exactly.
new array has a
Yeah.
probability that that one is the output, or
Yeah.
how likely that is to be the output.
Yeah, and the good thing about it is the probability that it would assign to class 1, and the probability it would assign to class 2, and the probability it assigns to class 3, if you add all of them together, it would be 1.
Yeah.
That's what it is doing. This is what is called a softmax activation. So it just simply takes the Z value for that respective neuron, plug it in the power of E, and it divides it with the Z values plugged in the power of E for all the units summed together. The result is you get a probability. If you add all of them together, it yields a 1. So then the way you, so like for every single neuron here, you'll get a probability because of the softmax activation. So maybe the probability this class 1 gets is points, let's say 0.7. The probability this class 2 gets is, let's say, 0.1, and the probability this one gets is 0.1. So the way then you compute the label from these probabilities is just simply pick the maximum probability. And the way we do it is by calling the np.argmax code line of code. You might see this in the CNNs when we'll cover a multi-class classification problem maybe, but we just simply pick the probability, the maximum with the maximum probability. That's how you can compute or you can handle multi-class classification problems in a neural network. Now, if you remember just one extra detail. This is That's how we handle multi-class classification. But we can also handle binary classification problem in this way. The way we do it is instead of having a single neuron, we can create two neurons at the output. Now, remember we are doing binary classification here using softmax activation. This would be Z1, this would be Z2. How do we compute the probability this? We just simply take E Z1 divided with E Z1 plus E Z2. And how do we compute this probability? We take E Z2 divided by E Z1 plus E Z2. Point that I'm trying to say here is you can also make use of softmax activation to do binary classification. And this is exactly what Nishant or what ChatGPT has provided the code for. It used the softmax activation to do binary classification. So binary classification can be handled both ways. You can use a softmax activation for it. You can also make use of sigmoid activation function on it. A more natural way of doing it is usually using a binary, so using a sigmoid activation function. Because if you would like to do it using softmax activation, the softmax requires you to convert the labels to one hot encoded. Because if you see here the three-class classification problem that we were doing, the output that this neural network would be taking, like the label, would be 3 values for every single example. So let's say we have an example where the true value is for class 1. So we'll have a 1 in the place of class 1 and zeros in the rest of the places. That's how an output true label for a single example look like if you are using softmax activation function. And that's why when Nishant handled this using softmax, he had to convert every single example to the one hot encoded version of it, where you have 2 values for every single example. So if it survived, let's say this is the survived and this is not survived. So if it survived, we have a 1 in the survived, 0 in the not survived. And if it was other way around, then we have 1 there and 0 here. I hope it's clear.
Yeah, that's super interesting. Hey, thanks, Naveed. Brayden, did you have anything that you wanted to show today as well? Were you able to train anything?
I didn't get to train any model, no.
Okay. That's fine. What was the data set that you wanted to use?
I was gonna use the same one that I used in the first week, which was the how likely you are to pass a class based on basically your grade in a certain class in school based on some set of features.
Yeah, that would be really interesting, especially because of the alcohol use versus student performance was extremely nonlinear, right? That would be kind of interesting to see. Cool. Well, we're pretty much out of time for today, but I think we mentioned a little bit like that now we're 3/5 of the way through the course. So for the next 2 weeks, it's pretty much open what we might do. But yeah, just curious, what are your guys' thoughts on topics that you really want to make sure that we cover before the course ends?
I'll leave this open in the chance, but I think what would be interesting is the next class, because we've kind of covered a lot of material or covered a lot of ground so far. If we could do a maybe open-ended little more discussion where we can kind of just come in and ask questions and then Naveed can explain any kind of doubts that we have or confusion.
Sure.
Are
Yeah,
you
I can do that.
ready for that, Newt?
Already. I have ChatGPT by my side, so no worries.
Prepare the hardest questions you can and don't tell him what you're going to ask. Okay, good. Trying to think what's the hardest topic I could think of. That's probably some good stuff. Nishant, what about you?
Yeah, I think that's a good idea. I like the idea of workshopping. That sounds like a good idea that Braden brought up. Yeah, I was thinking maybe go more in depth into the neural networks more, but I think
Mhm.
Braden's right in that we were kind of covered a lot of stuff. So maybe like a little backtrack so we can have time to go back to our labs that some if we didn't were unable to do and stuff like that, then or you
Yeah.
can like add more features and stuff like that, then that would be a cool idea.
Cool. Nishant, is there any data that or any kind of projects that you thought before or even before this class it would be really fun to do to use a neural network for? Like, did you have any projects in mind that you want to do?
No, no projects that I had in mind.
Okay.
Yeah, just mainly the concept itself was interesting, so I was just excited to learn about it.
Cool.
Yeah.
I think most likely we'll end up doing probably Naveed, right? We'll probably end up doing CNNs and then RNNs. So CNNs are for image recognition. RNNs are for time series forecasting. But those both build off of what we did today. We can't do them without what we did today.
Yeah,
Good.
for CNNs, the idea is simple, but the whole field of computer vision is standing on CNNs. So it would be a really good thing to at least have the knowledge of. The math is also very simple. For RNNs, the math is tricky, yet we also have like a lot of use for RNNs. Um, they start with this feedback loop, and then we also go towards GRUs, LSTMs, and then transformer is also basically then modeling a sequence time series data. So that is also a field of its own, although a little bit tricky as compared to CNNs. What we can do is maybe I just provide you a quick overview of how it works, the intuition. We won't go too deep into the math part of it. It's tricky and it would take a lot of time. Uh, but we can talk about its applications and how where we can make use of such things. So both of them seems okay to me. We can call that.
Cool. Then we'll plan for Thursday for CNNs.
Okay.
And Nishant, I will see you bright and early.
Sounds
Looks like the sun is up
good.
already, though,
Yeah, it is. Actually, it's very foggy still.
so we'll be fine. Yeah,
Yeah.
we'll be bright and awake.
Wait, which part of San Francisco are you staying in? Or like Oakland-ish, or what?
I'll be staying in next week. I'll be staying near North Beach.
North Beach.
Did you get the same apartment that you were in last time?
No, Braden. Braden and I shared a place. No, Braden, I don't know.
Not really. But we lived in the same building.
Yeah, that's it. We lived in the. It was a. We shared a floor in North.
Yeah.
No, not gonna be there. Unfortunately, however much I love that. I love that house.
Okay.
It was best
Thank you,
because
guys.
I got to see Braden in the kitchen in the morning.
Okay, guys. I'll see you then.
See you Thursday.
Bye bye.
Goodbye.
See you Thursday.